Okay, again, we've been doing a lot of formulas and how we get formulas, but let's solve some actual problems here with numbers to help you see the process a little bit better. So let's do a cliff problem. In this case, it's not really a cliff, it's going to be more of a table, but you've got the same situation here. A bowling ball, and it's going to roll off the table at a velocity of 5 meters per second, and it's going to fall off a table that's 2 meters high. We want to know what's the range of the ball. How far away from the edge of the table when it falls off is it going to go? So there's a couple of things we need to know. If we're going to find the distance it's going to travel, we need to know the velocity and the time. Well, so the distance in the x direction, or the range, is going to be velocity in the x direction times the time. Well, it's pretty simple because the initial velocity in the x direction is always equal to just velocity in the x direction. It's not going to change at all. Now our time is going to be affected by gravity. How hard does gravity pull it? Well, this is one of those situations where we have a number that we're not given, but we know it. We know that gravity is equal to negative 9.81 meters per second squared. And then we also know that it's 2 meters high. So to go ahead and calculate this, you know that distance is equal to 1/2 AT squared. We could make this y equals 1/2 GT squared. So t would be equal to the square root of 2 times y over g. All right, fair enough. Now, if we want to know, we can go ahead and do the time if we'd like, or we could substitute this whole thing into that formula. Let's go ahead and do the time separately. Time is equal to the square root of 2 times y over g. And what we're going to get is 2 times 2 meters over negative 9.81 meters per second squared. You can see in this formula, they've got a negative here. We're going to end up with a negative under the square root. So there's a couple of different ways I guess you could handle that. You could just say, look, I just need a time. I can't have a negative time. And you could do away with that negative symbol there. Or you could, I guess, express this as a negative 2 meters since it's going downwards. You'll end up with a positive number. I'm just going to choose to ignore that negative and take it out of here. So I'll end up with 4 divided by 9.81. I'm going to take the square root of that, and I get 0.64. And then I'm underneath the bracket here. So meters divided by meters per second, those meters go away. I have the inverse of 1 over second squared, which is seconds squared. And I take the square root of that, and I get seconds. So it takes 0.64 seconds to hit the ground. Well, if I want to know how far away it's going to go, the distance in the x direction is just going to be 5 meters per second times 0.64 seconds. And because this wasn't specified here, we're just going to assume it's exactly 5 meters per second. That keeps us 2 significant digits. So we're going to have 3.2 meters. So that object's going to land 3.2 meters away. And that's pretty far. 3.2 meters is about 9 or 10 feet. So that bowling ball is coming from 6 feet in the air, and it's going to go 5 meters per second, which is pretty fast. And it's going to land about 9 or 10 feet away. It's a pretty fast bowling ball on a big distance. But that is the correct answer.